In this lesson, we're gonna walk through the process of creating your front-end project. We're gonna use Create React App with TypeScript and ethers library. So let's find Create React App website and click Get Started. Search for TypeScript and pick adding TypeScript. Now let's bootstrap your whole front-end application just in one command. Copy it, go to terminal, paste, and just change the name. What I'm going to type here is the name of my project and also the name of the folder within my project is placed. So let's call it blockchain frontend course. Check everything is fine and hit enter. Now my project is being created, and if everything goes fine, I get a message. The message should say success, give you example commands, and also should say happy hacking. So npm run start, hit enter, and see what happens. Open your browser and head over to localhost port 3000. You should see the default screen like this and no errors in the console. Let's change something in the code. Open app.tsx. Let's shrink terminal a bit, but keep it still visible to see what is going on in our project. If something goes wrong, we will see it here. Now let's remove the default content and I type just greeting like this. Now see results in the browser and it works great. Next step is important. We want to print the data which comes from blockchain. So now we stop the server and we're gonna install ethers library like this. npm I like install and ethers. Hit enter. If it's done, and if I go to package.json, I can see ethers.js on the dependencies list. Let's close it. Once ethers.js is installed, you can create a provider by typing in the app.tsx file const provider equals ethers imported from ethers library and get default provider. We need that provider for blockchain communication. Provider establish a communication with blockchain. However, you can see there is something wrong. There is missing argument because get default provider expects a provider URL. We're gonna fix that in a minute. In order to get that URL, head over to chainlist.org. Next, search for girly chain. Girly. Like this. And you need to check this checkbox to include testnets because girly is actually a testnet. It's girly. Don't confuse it with optimism girly testnet and other girly may appear here. It's just girly with chain ID 5. Let's expand it by clicking this button. Now we see the list of girly RPC URLs. Copy whatever address from the list and pass to the function where the argument is missing. So I copy the first one, go to the code, and I'm gonna paste it as an argument in as a string, and the error is gone. We got provider, and the next thing we need is a smart contract, but don't worry, I already deployed a smart contract for you. This is the smart contract address we're gonna use, and this is its ABI. Its ABI is also needed. We're gonna talk about ABI later on in upcoming lessons. For this lesson purposes, just copy this code. Everything is available in the description. Now it's time for creating the smart contract object. So let's type const greeter contract equals new ethers contract, and checked what arguments this contract constructor receives. The first one is target, a string. It's actually the address of the smart contract. The second one is ABI. So let's pass ABI. And the last one is provider. It's called runner here. Okay, variable name is greeter contract, and the constructor accepts all the three variables we created before. So having this smart contract abstraction, this smart contract object, we can call the smart contract method just in the React component. In the next step, we create a button inside the header node. Like this. Let's have a label saying greet. On the click event, we're gonna fire a method called also greet. So let's create that function. That's function for that event. Const greet. Let's take a greeter contract dot, and here I can type the method on the smart contract. It's also called greet. TypeScript doesn't work at this point. Let's ignore that. We're gonna call that method greet method, and we need to use an await keyword because this function is asynchronous function. And let's put the result into variable like this, and print the result into console. I see an error pops out here. This is because an await keyword is allowed only in the async functions. So let's put the async keyword here, and the error is gone. So far we print the button with the greet label, and when users clicks that button, the greet function is called, and the greet method on the greeter contract is invoked. The result is put into console, and what we gonna see at this result. Let's see. Let's start the server. So npm start. Go to the browser. Let's zoom in a bit. I see the button with greet label. I click that button. Then I see the hello world message in the console. Okay, the question: how do I know this message, this string comes from blockchain? I know it because I provided the API, which is valid for that function, and this function returns a string, what is specified in here. The last thing I want to do in this lesson is to print the result in here. To achieve that, I need a state, a React state. So let's have a state using useState hook from React, and this state, let's call it greeting and setter to be set greeting. We can also specify what's the type of the greeting. It's string, and let's use this set greeting setter to save the result into state instead of printing that into console like this. Now we can use the greeting variable, the greeting state in here. Just paste the greeting into handlebars and see what happens in the browser, of course. So restart the app, refresh the page. Now the greeting is nothing. This place is empty. And when I click the button, the greeting appears here. Before we go further, I like to make my app prettier. In order to do that, I'm gonna install Bulma, which is CSS framework, and it's also considered as library for UI components. I like Bulma because it's easy and straightforward to use. They highlight there is no CSS knowledge required. Of course, you can use any other CSS framework you like. We won't focus on CSS features in this course. I just want my app looking pretty. The prettier an app is, the better is also the developer and the user experience. So head over to Bulma landing page and let's see what's needed to install Bulma in your project. The installation script is available just in the header, so let's copy it and go to terminal, paste, hit enter and wait for the package to be installed. Once Bulma is ready, go to index.tsx and import Bulma CSS code into your project like this. Now Bulma code is available globally in your project, and the only thing you need it's just to use the desired class name for your HTML. So let's go to app.tsx, and for now we need a class name for this button. So let's grab it, go to documentation by clicking getting started. Now in the left hand side menu just click elements and then button. If you scroll down over this page, you can see a lot of sizes and colors. However, we're gonna pick this class name button and its primary to make our button like this one. Go to the code, put the class name and see result. Run the application npm start. And we see the button is exactly as we wanted. At this point, my recommendation is to look around the Bulma project and find some cool stuff here. In this lesson, you learn how to use basic APIs and basic data types. And the first question is, why you need to load ABI for the front-end app? And the answer is, once you provide ABI, ethers library is able to encrypt and decrypt data. So the ABI is necessary when you want to ask blockchain for data and also when you receive that data. Without ABI, ethers.js doesn't know how to ask questions and how to read code up informations. You can also consider ABI as a schema for your smart contract. Let's have a look at ABI we already have in our project. It's this. So what is it actually? We see some text with function keyword that's similar to JavaScript function definition. There is also greet, which means the name of the function. We also have other words, however, return seems interesting. What you see in the round brackets next to the returns word is the returned type, the type of returned data. In this case, it's just string. It's simple because we exactly know what string is in JavaScript and TypeScript too. It's just any string of characters between two single quotation marks. Okay, we got an array with a string inside. Some text inside an array. Why array? Because we can have multiple various functions in just one smart contract. Let's have, for example, an ABI which contains 4 functions, like this. We also need to pass an address for this smart contract. That's completely new smart contract though. Is this. To recap everything what we already covered. And the 2 things you need to pay attention at is the name of the method of the smart contract method and the return type of the smart contract method. So following this ABI, there is a function, there is a method called active. The name of that method is active and the return time is boolean. The next method, it's called name. The name of that method is name and the return type is string. You can ignore the memory keyword here. And then we get another function called state, which returns something which doesn't exist in TypeScript nor JavaScript. It's type uint8. And then we get another function code which returns uint256. What does it mean? What does uint8 mean and what does uint256 mean? For now you can assume both are just numbers. They are some special numbers, however we're gonna talk about that later on in the upcoming lessons. In this lesson, you learn what different data types looks like. Let's call each of these functions we covered in previous lesson. I've prepared a template based on one of the first lessons, and if you wonder how to create this layout, just check the code in the description. Now we focused on the ABI. We need to change the name of the smart contract object. It's no more greeter smart contract. It's gonna be store smart contract. Okay, let's call the first method of the store smart contract. It's active. We already know we need a state. So it's gonna be is active and the setter is set is active. The type is boolean. This is the TypeScript boolean. And here is the boolean type from the smart contract ABI. Next we have function for calling that smart contract method on the store smart contract. We call the active method. We did something similar in previous lesson, so I'm gonna fast forward that. Now we're gonna have a button for triggering that method, and everything is gonna be wrapped by the block column component I created before, and it's here. It's just a wrapper. Now it's time for a button. We're calling this method, and we want to show the data. The state is active, but it's a boolean. We use in React we used to show boolean values like this. So let's have an active text, and we're gonna display that text in the paragraph like this. Okay, what we got? There is a button. When I click that button, the check is active function is fired. Then we call the smart contract method. We save the result into React state. if the active state is undefined, so the button haven't been clicked, we display 3 dashes. It means the value is not available yet. When its active state is available, after we click the button, we should get true or false value. But in React, if we want to show boolean values, true or false, we need to convert it into string. So that's the method I recommend to do that. Let's see what we have in the browser. There is a button. If I click that button, the true is displayed because the smart contract method returns true value. To make sure what we get directly from the smart contract method, I mean the result value, we're gonna console log that. And let's have what is in the browser in the console log actually. Refresh the application, click the button, and there is a true. It's a true, it's a boolean. Next method is name. It returns string. It's already covered, so I'm gonna fast forward that. Steps are same as in the previous one. We have state, another function for calling, and the block component for displaying the button and the value. What's in browser? We get another button, get name. A value is not available. If I click that, the name is displayed. If I put console log here, I'm checking the result value, what it exactly is. Let's save, go to the browser, refresh the app, click get name button, and it's a string. We see it's a string. Okay, we already have called 2 methods of the same smart contract. There is a active method on this smart contract, on the store smart contract, and the name method on exactly the same smart contracts. So let's call the third one, the third smart contract method we have here is a state, and it returns a number as we remember from the previous lesson. U and 8 means it's a number. Let's grab the state. First, we're gonna have state with the use state method from React, and what we see here is a BigInt type. Is a special type for that number. So let's see what that number actually is. So as usual, another function get state. We call the state smart contract method. We're gonna have result. I'm already put the result into console log and set state from there, and we have to display the button and the value. The button is here, get state, and also a paragraph with the value. And what interesting here, we're not allowed to display the state, which is the BigInt type, directly into JSX. We need to use the toString method on that object, because everything which has the dot and we can call the method on that is considered as an object. So that BigInt number, we can consider that like some special number, which is also a object. Let's check what we have in the browser, but first I'm gonna display the result this way. Go to the browser. We got another button, get state. Let's click it. The value is 7, okay, but what's in the console? It's a 7 with the n suffix. Okay, hold on for a while and let me explain to you what's that. What is 7n? That value 7n is the actual BigInt value. BigInt as a special type that has been introduced to JavaScript not so long ago. And if if we go to the documentation, in the examples here, we see it supports only integer numbers. I mean, it doesn't support numbers with decimal point like 3.14, and we cannot perform the math library of that numbers. Here we have another examples, and in terms of operators, we can perform adding, multiplying, subtracting, modulo, which is actually dividing here, and raising the number to power. I really encourage you to get familiar with that page, with that documentation. There is also information that bitwise operators are supported, except that one. The unary operator is unsupported, and regular dividing it works, but the fractional result will be truncated. And in the end, so far we see the BigInt type is pretty well supported in almost all the browsers, except Opera, only partially, so you can feel comfortable using the BigInt type. If you struggle with some operations with BigInt type, you must visit this page. If I go back to the console in the browser, and if I tap 1, 2, 3, and I see the output as this. So let's try with something weird, something which is considered not allowed. 1, 2, 3, point 4, 5, 6, n. And we got the syntax error. This expression is not allowed, is not readable for JavaScript. So only whole value numbers are supported. Don't try to use it with numbers with the decimal point like this one. The last one method left, it's code, which returns uint 256, and I'm gonna fast forward that, and let's see the result in the browser. Boom, done. If I click the button get code, I see the number in the cursor is really big. It also has n in the end. It means this is the BigInt type. So in case of uint 256, the case is exactly the same. We use the BigInt type. When you type a BigInt number expression like this, you can spot a TypeScript error like this. BigInt literals are not available when targeting lower than ES 2020. That means you need to change the configuration in your TypeScript tsconfig JSON file. You need to change the target option for at least ES 2020. Once I did that, the error is gone. In this video, you learn what's the difference between BigInt JavaScript type you see on the right hand side and the BigNumber objects you see on the left. BigNumber is used in ethers.js library in version 5 and below, and also in web3.js library you must spot in some legacy projects. We can consider BigInt type like a native JavaScript solution. On the other hand, BigNumber is another solution for handling number values from smart contract. This is a library and it's included in ethers.js in version 5 and below, like I said before. You may see it in the projects which exist for a long time and you can possibly join them. Currently, if you install ethers.js library, by default it is in version 6. So I'm gonna dump it from 6 to 5. Let's say in the package.json was version 6 and now is 5. If you want to install something in version lower than it's as default, just type npm install ethers or any other package name. In the end, type @ and specify the version. In this case, it's 5. Perfect. Now I see BigNumber library is available, the error is gone, and this code is equivalent to the code on the right hand side I showed you in previous lesson. To create BigNumber objects, we use the from method on the class BigNumber, and value passed into the constructor can be a regular number or even a string which contains digits. Like this, passing a number is correct, a regular number, and passing a string with digits and sign is also correct. If I pass to the constructor something which is incorrect, like this, then I won't see any error here and in the code editor. I will see an error only in runtime when this code is actually running. On BigNumber objects, I can perform exactly the same calculations like on BigInt type. However, all of these calculations are available under the methods instead of operators like plus, minus, asterisk, or slash. I can add some value to existing BigNumber object just by using add method, and I also need to pass an argument, and this argument can be a regular number, can be also a number in string, and also another BigNumber object. So all of those calculations, all of those combinations are possible. I can also subtract values like this. I can also chain the operations like this. So I call one operation and then in the same line, in the same expression, I perform another operation without saving the temporary value in variable. So I can add values, subtract, divide, multiply, and raise to the power. There is a lot of available operations you can check just by typing code into your text editor and prompting TypeScript for available methods under current object. Just move the cursor to the end of the expression and type dot. Then you see available methods like equal, from twos, and others like greater to, equal, is negative, is 0, lower than equal, modulo, logical operators like or, to number method, to JSON, and also to BigInt, which is interesting because we can easily switch between BigNumber type and BigInt JavaScript native type. So this code is equivalent to code like this. Let's cast price 3 into BigInt like this. Then we add 5. So let's add 5. Subtract 3. Divide by 2. Also, the order of the operation And here is line, it's going line by line. In this case, we need to remember different operators have different priority. So in this case, we need to use something like this. Well, I forgot to put n here and put n here. Then I multiply by 10, also 10n, and rise to the power of 2 like this. This code and this code is equivalent. In this course, we won't use BigNumber objects if it's not the subject of the lesson. By default, we're gonna use ethers.js in version 6, which supports BigInt type already. I missed one thing. Rising to the power has higher priority, so to have these expressions really equivalent, I need to put everything what we got previously into additional parentheses, then rise to the power. Welcome to the lesson on reading data from external smart contracts, especially blockchain oracles. In this lesson, you'll discover how to access data from third-party providers for your decentralized application. So, what exactly are oracles? From a front-end perspective, oracles are simply regular smart contracts. However, what sets them apart is their ability to act as data sources for real-world information. While blockchains themselves cannot fetch data from external sources like REST APIs, developers often need access to it anyway. And this is where Oracle smart contracts come into play. They are specifically designed to hold and provide sensitive data, which often drives internal economies within applications. For example, let's say you want to calculate the cost of certain operation in your application, but the cost is priced in dollars. To determine this, you need to read the current Ether price in dollars, which is a real-world asset. Oracles can provide this information to you, and the best part is reading data from oracles is always free. And this and upcoming lessons will focus on Chainlink Oracle as an example. Chainlink provides a variety of data feeds that you can access. One such data feed is the Ether price in dollars, which can be found at the following link. Head over to data.chainlink.link and pick ETH/USD. Remember, this oracle is essentially a smart contract, so to interact with it, you'll need to know a few key details. First one, the blockchain chain where the oracle is deployed. In this case, it's Ethereum mainnet. The second, the smart contract address of the oracle. You need the address of the smart contract oracle. And the third point is the ABI. The ABI is application binary interface of your smart contracts. And this page, the page of the oracle we want to use, right there you can find the chain name and the address. But there is no ABI available to download. Don't worry, in next lessons I'll teach you where to get the ABI from. So far, Chainlink is currently the most famous oracle provider on the market. However, there are many other providers available. In the upcoming lessons, we'll dive deeper into using Chainlink oracles to read data in our application. Remember, reading data from the blockchain is always free, so it's a valuable resource for every developer. So, get ready to explore the world of blockchain oracles. See you in the next lesson. Welcome to the next lesson where you learn how to download the ABI, which is Application Binary Interface, in JSON format from etherscan. But first, let's talk about etherscan. Etherscan is a powerful website or web service that provides various data about deployed smart contract on the Ethereum blockchain. It offers features such as checking transaction status and details, among others. There's a lot more, but I'm not gonna talk about them now. In this module, we'll be working with Ethereum mainnet, and etherscan is a tool for obtaining information from that chain. We're gonna use etherscan to download ABI for our Oracle smart contract. Head over to etherscan.io and you'll see a search bar on the home page. You can paste here various data you want to look for, paste the smart contract address you want to explore. In our case, we'll use the chaining ETH/USD Oracle smart contract. Go back to chainlink ETH/USD Oracle page and ensure that you have the correct smart contract address copied. Paste the smart contract address into the etherscan search bar and hit enter. etherscan will retrieve a wealth of information about the smart contract, including the name of the contract, its creator, a list of latest transactions, and the smart contracts code. Find the contract tab and click on it. This tab contains specific details about the smart contract. Continue scrolling until you reach the contract ABI section. You'll see a large block of text in the scrolling area, which may seem overwhelming. Don't worry, this is because the Oracle smart contract has many methods and the ABI includes all of them. However, we'll be using only few. Create a new empty JSON file for the ABI. Let's name it abi.json. Copy the entire content of the contract ABI section from etherscan. Paste the copied content into the abi.json file you created and save. Whoa! Now you have the ABI ready to use in your front-end application. See you in the next lesson. Welcome to the next lesson where you learn how to find the provider URL for your chain. The provider URL allows your application to connect to the desired blockchain network and interact with the smart contracts deployed on that chain. First, you need to know the name of the chain you're creating the application for. In our case, it's Ethereum mainnet. Visit chainlist.org. This website provides a comprehensive list of different blockchain networks and their associated provider URLs. Ethereum mainnet is the first one, so we don't need to use the search bar. Expand the list for Ethereum mainnet by clicking the arrow icon next to it. This will reveal the list of available providers for that chain. You can choose any provider from the list based on your preferences. For the sake of this lesson, let's pick the first provider. Copy the provider URL. Now navigate to the code you've been working on for your application. I prepared a code template before based on previous lessons, so nothing new here. Paste the copied value into the appropriate location. Please note that in this lesson we're focusing on finding and obtaining the provider URL. The code template and its usage will be discussed in more detail in the upcoming lessons. You can find the code template and related links in the description. In the next lessons, we'll delve into using this provider to connect to the Ethereum mainnet and interact with the Chainlink Oracle smart contract. See you in the next lesson. In this lesson, you learn how to call the methods of Oracle smart contract. We got the provider URL, it's ready, And for ABI, we're gonna use the file, the JSON file we prepared earlier, so we don't need this line. And we also have the contract address of the oracle we're gonna use, so let's paste it here. Now we can start reading the values from the blockchain. Likewise, in the previous lessons, I will call a smart contract method when the button is clicked. It's get if price here. Then I will show its value in the console and also on the screen. In the screen, it's here. We store the value in the React state. And it's not gonna be string now. Let's leave it in that form. Let's grab the value using following code. Const result equal await. Then we're gonna use the oracle smart contract, and on it there is latest run data. Let's see what's the result received from the smart contract. So console log and put it here. Now go to the application, click the button, and we see something like this. We got some weird proxy object which contains something looking like array. However, it has field called hash names, and it's also an array. That array, or rather a tuple, has 5 values inside. We can access each of these values by array index. I'm interested in the second value of the tuple behind the index 1. Let's check it. Go to the code and once again console log. However, this time it's gonna be index 1, so that's the second value. Save, refresh the app and click again. It's some BigInt value like we see here. It's the same. But how do I know what are all of these 5 values, and how do I know the second is the right one? Look at the hash names field on the returned structure. When you expand it, you'll see the list of the names for each tuple value. You can access these values also by its name. I'm going to do that now. Instead of accessing value by array index, I use the object notation. The field name is answer. Let's put it here and see what's the result in the console. So I'm clicking the button and I see this value, and also this value. That's exactly the same value. At this point, it may be confusing to you that some structure is an array and is the object at once. That's the JavaScript magic. We know that the answer is some BigInt we see here. So let's store that value in the React state and show it on the screen. Let's try with this. Leave it. Refresh the app. Fetch the data again. And we don't see any value here. Nothing is displayed because we have to use toString. We need to provide the BigInt type here. Then we're gonna use toString method like this. Again, and we see some enormous value here. What's that? The actual value is 1800 and above, and we got something like this. Do you remember that BigInt type can hold only integer numbers? That's it. Even if the value have some sense, we cannot store fractional value with the dot notation on blockchain. Instead of that, we keep the whole value and its fraction in integer, like this. Let's examine how many numbers we need to cut to get the desired integer value. The actual value is over 1800, so let's count from the right side. 1, 2, 3, 4, 5, 6, 7, 8. It's 8, that's right. If we put the dot after 8th digit counting from the right side, then we get the price of Ether in dollars. But why 8? Is it always 8? Can we assume that decimals are always 8? And how to show the full value, integer and fractional also, like we do in human world. We'll do that in the next lesson. See you! In this lesson, you learn how to display BigInt numbers with a nice dot notation, readable for humans, for the people. First, let's figure out what's the actual decimal point for the oracle value. Open abi.json and search for decimals. Then you see the following output. We see that chaining oracle we're using, it provides a view function called decimals. It holds an information how many digits we have to cut off to get the actual integer value. In the previous lesson, we already figured out it's 8. However, we can fetch that information from the smart contract. Go to the code and get rid of those console logs and React setter. Then we can call a decimals method. Let's have a variable decimals equals await, the same, some smart contracts again, and the method is decimals. It's also decimals, and then we can print the value into browser console. Let's have console log and decimals right here, like this. Oh, I forgot S here, and let's see what's in the browser. Click the button, and that's the proof we've been right. It's 8 for sure. If we already know what's the value and where's the decimal point, we can display the number in the nice format for the user right here. In order to do that, we're gonna use format units from ethers library. It's important here, and let's assign the returned value into if price variable like this. This function accepts 2 arguments. First one is the value we want to display. It can be BigInt. The value is result.answer. And the second is decimals. It also can be BigInt, like our decimals. Okay, let's move the console log here, and instead of decimals, we're gonna check what is if price. Go to the app, refresh, click the button, and it's a number in nice human readable format. It's 1806.53. Let's check that value matches the value on the Oracle page. It does. Perfect. Now we can store the value in React state like this. It's no longer BigInt, it's just string. Get rid of that console log, and also get rid of the toString method, is no longer needed. Let's see what's in the browser. We expect that value here. Click the button. Perfect. Hey there, in this lesson we're diving into chains and smart contracts. So what exactly are chains? Well, you can also think of them as networks, kind of like different realms in the vast universe of web3. Now let's jump into our wallet, which is MetaMask. Right at the top, you'll notice the chain list. Click on this menu to reveal a bunch of available chains. In this lesson, we're going to play around with the Sepolia chain. That's a testnet. It's completely free for you to experiment with. That's our test lab. But hold on for a while. There are other chains hanging around here, like mainnet. Make sure you're running on the right chain. We'll get into how to prompt users to switch networks later on. For now, just keep an eye on the selected chain right here. And my advice is think of chains as separate words for smart contracts and by extension, your applications. Whatever is accessible on one specific chain, that remains exclusive to that particular word. Chains don't cross. They are like parallel universes, unable to have a chat with each other. Now, you might be wondering, why not just have one chain to rule them all? Well, each chain serves a unique purpose. Take Ethereum mainnet for instance. It's the go-to for top-level applications. Even though the transaction fees could be really high. Sure, developing on Ethereum is expensive, but it's the most stable and secure chain out there. But fear not, there are other chains fixing different problems like scalability or those high gas fees. You can even run a test blockchain right on your local machine, on your local computer. EVM stands for Ethereum Virtual Machine. So all EVM compatible chains are pretty much the same when it comes to coding. So whether you're dealing with Ethereum, Sepolia, or any other EVM compatible chain, the coding approach remains the same in terms of smart contracts and frontend. Remember, a smart contract is like a program that's been deployed on a specific chain. Smart contracts can talk to each other, but only if they are on the same chain. They cannot talk across chains. In Web3 community we say they cannot perform cross-chain. Hey there! In this lesson we're gonna deploy a sample smart contract for testing purposes on Sepolia testnet. Even it's not part of front-end developing, it's really important for you to deploy your own smart contracts you can deal with. Because if I deploy a smart contract on Sepolia networks, it's going to be common for all the participants of this course. So I expect if one person make a transaction, then it breaks someone else's result. So to avoid this problem, I recommend you to deploy your own smart contract or Sepolia network. Don't worry, it's really easy and straightforward, and I'm gonna guide you through all the process, so follow me. Okay, so the first step is just to make sure you have a MetaMask wallet already installed in your browser. If you open a window with MetaMask wallet, there is a list of chains I showed you in the last lesson, and look for Sepolia network. If it's not present in your list, just make sure you have this toggle on, show test networks, and even if there is no Sepolia network in here, go to chainlist and just search for Sepolia network and just click add to MetaMask. Then go to Sepolia Faucet. Sepolia Faucet is a web page where you can get your free Sepolia ETH tokens into your wallet. I already mentioned that Sepolia is free to use. It is because you can get that Sepolia ETH for free, some amount. However, you need to register your wallet, your account, and provide your address and click send ETH to get that ETH tokens for Sepolia network. So I'm gonna do that. First, go to MetaMask. I already have some Sepolia ETH in my wallet. However, I want to have more, so I just copy my address. I want to paste it here, but first I need to log in to Alchemy. Alchemy is a web3 platform. So sign in via Google account. Okay, I'm a human. Okay, get it. So now this input is available, but I need to click I'm not a robot. Okay, let's fill that captcha. Buses. Yeah, so they really protect the network from draining the Sepolia ETH by bots. So now I can get my ETH. Okay, I've done this before. There need to pass 24 hours to faucet be available again for me. However, at this point you can get your Sepolia ETH into your wallet. The next step is deploy your smart contracts from Remix IDE, which is a browser-in IDE for smart contracts. And I really recommend that tool if you want to start your journey with smart contracts in Solidity language. But we're gonna use that only for deploying one smart contracts, and we won't write the smart contracts on our own. We're gonna use the first already prepared smart contract, which is called Storage Sol. And as you see in the left hand bar, there are some tabs. First is just File Explorer, Search. Next one is Solidity Compiler, and the fourth is Deploy and Run Transaction, and that's the desired one. Let's go into it and pick the environment, which is injected provider. It's your MetaMask wallet. Click it, and now you see there is a Sepolia network. There is account with Ether displayed in here, so that should match the account you have in your MetaMask wallet. Make sure that this select is correct. Now I have to select my desired contract to deploy, but this select it's disabled, so probably I need to go and compile my smart contract. Make sure your smart contract is available on the right hand side in the editor, and this button with the correct smart contract name is available here. Let's click it. Yeah, it's compiling with no failure, and now the green deploy button is available here. Let's click it, and your MetaMask wallet should prompt you to confirm the transaction, because contract deployment is actually a transaction. You can also explore all those things here, but I just click confirm just to confirm I want to deploy my smart contract. Okay, we see some logs. We see the deployed contracts, and there is some item here. So you can deal with your smart contract deployed on Sepolia network now. Okay, here we got controls for both of smart contracts functions. First one is store, it's store button, and retrieve, and there is retrieve button. Let's click retrieve, and we see there is a value 0 and it's nil. So let's store some number 1, 2, 3. Store, that's the smart contract transaction, so we confirm that. Okay, let's wait for transaction to be mined and click retrieve again. So now you see the value is 1, 2, 3. So you got controls to deal with your smart contracts. However, we're gonna deal with this smart contracts. Yes, particularly this smart contract. You can grab the address of this smart contract right here. we're gonna deal with this smart contracts via our front end. So we're gonna build a display where you see the current value of the stored value, and the controls to trigger the transaction from your MetaMask wallet. So that's it for now. Remember, this smart contracts address is unique for the smart contract has been deployed now, so it's going to be unique for you. Everyone else who deployed exactly the same smart contract the same way, the other recipient of this course, they're gonna give another smart contract address. The address is gonna be completely different, even if it is the same smart contract. And also keep in mind that if save this smart contract address if you want to use this smart contract in your front end, because if you reload the page, everything is gone. So either keep this tab always available during your development, either just save the smart contract address up front. Hey there, we're going back to coding. In this lesson, we code our first smart contract transaction from frontend. So we're gonna trigger a transaction into your wallet from the frontend side. Okay, let's see how our frontend application look like in the browser. So let's start yarn start. It's running on the port 3000. So let's run localhost 3000, open also the console. And that's our old app from previous module. We're gonna maybe not get rid of that, but hide it. So let's move everything what is an app component right into components and just call it if price. Then go to the app component, get rid of everything in here and here, put some fragment, and the component is if price. Let's make sure the name of the component is also if price, and import that component in here. Now everything remains the same. However, we have some importing errors here. Okay, everything remains the same. However, now our main component is clear. Also, we see that ABI it's in the root folder of our source code, which is etherc. We're gonna move all the ABIs to separate folder, and it's called ABIs. Okay, let's move ABI.json to ABIs folder, and to market the specific ABI for our if price contract, we're gonna call it also if price. However, we know it's just ABI because it's inside ABIs folder. There is no way for confusion. Now we see the error, importing error in the component if price, and it's no longer in the root, so it's an ABIs if price. Okay, our code base has been tidied up a bit, so now we can start the actual job. Let's create another component. It's store tsx. Let's print something into screen to make sure component works. Store if price, close it, if price JSON, close it, and app like if price Okay, let's check in console, and store is printed here. In the store component, we're gonna use exactly the same code and skeleton like in here. So let's go to if price tsx component, copy everything and put in store component, but keep the component name the same, so store. Now we should see twice, so let's hide the old component and focus on the store. Hold on for a while and let's figure out what is different in our smart contracts and the smart store smart contract. The first thing is provider. Provider URL is no longer gonna be provider for Ethereum mainnet. It's we operate on Sepolia test network, so it's gonna change. Let's get rid of that. In terms of smart contract address, it's also gonna be different, and we already know what is the smart contract address. Let's go to Remix IDE. We deployed the smart contract address. We deployed the smart contracts in the previous lesson. Click this button to copy the address and put it here. Now let's find the provider URL. So go to chainlist and search for Sepolia. Just make sure include testnets is checked. Sepolia, there are other Sepolia's network, so make sure you use the desired one, the correct one. It's Sepolia for if it's called just Sepolia. I just recognized that chain ID, so I know it's correct. Let's grab whatever address from that list. So let's go with this and put it here. So provider is okay, address is okay. However, ABI is not correct. To find the ABI, just use Sepolia network etherscan. It's a block explorer for Sepolia network. And now we need the smart contract address. Let's search by smart contract address. And we see there are some logs here. We need to go to contract and find ABI. Contract code and ABI. Copy ABI to clipboard. Okay. And create another file. Let's call it store.json. And put ABI here. Maybe let's format it, and we see there are some items referring to particular smart contracts function. Okay, let's save it, close it, and link into our component. ABIs store.json. Okay, it's correct. API is used here. That's fine. Let's have a look at this code overall, and so far we have configured provider and the smart contracts. Everything is ready to be used in the component, but smart contract name is store contract. Okay, let's adjust the component. Maybe just get rid of this and this. Okay, let's have this line and figure out what we're going to store in state. It's not a string, it's a BigInt, and the state is just value, and set value. The callback name is get value, and we're gonna use the store contract here, set value here, with the result. And this is to avoid mistake, I go to remix and copy that function name. Now it's no reading, it's actually reading from smart contract. Let's stay with it, but it's not. Oracle is a store contract. Okay, it's this callback. On click on that button and get stored value here, value. If value is available, it's not undefined, then value to string, otherwise let's display 2 dashes. Yeah, that's it. So when we adjusted the code from previous lesson, because reading is pretty much the same, and we expect when we click the button, the stored value will be displayed in here. Why? Because the value, the variable called value, has a state, and state is a result of store smart contract call, and we know we call retrieve method of store smart contract. It's exactly what we get here as a control and a button. We can click it and we see there is 1, 2, 3. Let's have it 555. We need to store the value first. Let's have it. Let's wait the transaction to be mined. Let's click retrieve. It's 555. We see also some logs here, so we sure that the smart contract method call occurred. So we expect that in that result of retrieve method, the result is 555. So we set that into React state and display here. But this function is called, this smart contract method is called only when the button is clicked. Okay, let's test it in browser. Make sure React application is running. Go to browser and I see get stored value button. Click that button and we see exactly what expected, which is 555. Let's adjust content a bit. This module is about writing, so let's put the writing to smart contract in the title and adjust subtitle, store a number in a simple smart contract. Button says get number, and we can use optional chaining in here with or. Okay, works, done. We can also test if we change the value in the Remix IDE, for example for 444, and store that value. Okay, we expect here this value is no longer 555, it's gonna be 444. It is. Let's test it in our app. So if I click that button, this should be 444, and it is. So the test passed. That's it. In next lesson, we will create controls for storing value in the smart contract. Hey there, welcome to the next lesson, which is about connecting browser wallet. And before we send transaction to blockchain, as I promised in the last lesson. Before we do that, we need to connect our wallet to our front-end application, to our dApp. So we must have wallet to be able to write to blockchain, and our wallet is of course MetaMask. MetaMask connected to Sepolia network as our dApp too, but our dApp is connected via provider yet, not via wallet. That's the huge difference. Why is this a huge difference? Because this provider is able only to read data from blockchain, but to write data to blockchain, we need wallet. Wallet is basically another kind of provider, but with some abilities to sign a transaction, like we saw in Remix IDE. Every time we click store, MetaMask prompts us to sign a transaction. So this application, Remix, is connected to our wallet, and wallet prompts me to sign a transaction every time I trigger the transaction from this UI by clicking store button. So we cannot use this provider, this URL, to sign transaction, to send transaction, to write something on blockchain. So far we know the provider and wallet are kind of two communication channels. The first one, which is provider, is able to only to read data, and wallet is able to sign data, to write data, but is also able to read data. But for reading data, we use this provider, which is called default provider or public provider. So you need to have a native currency of a certain chain, which is Sepolia ETH, Sepolia Ether. We need to have it in real world and real chain, production chains like Ethereum mainnet or Polygon. The native token is worth something, is worth a lot. So you need to pay to contribute to that chain. So that's why you need to have wallet, and public provider is not able to sign a transaction because it's not a wallet. It doesn't have any fund to cover your fees, to act in behalf of you. Okay, so create some component and call it wallet TSX and put whatever inside just to make sure the component is printed in the application. And now print this component in store TSX, in another component. Link it and test in the browser just to make sure it works. Go back to wallet TSX and we want to print a button. That button is responsible to connect your dApp to your wallet. So it should say connect your browser wallet, or just connect browser wallet. Okay, let's put some class name button to get it looks a little bit nicer. And what should happen if user click that button? It should invoke a function. We call it connect wallet, and we need to create that function. Const connect wallet. And what's inside? First, we need to take a variable called Ethereum, and we grabbed it from window. Window is an object which refers to the global scope of your browser. So if you have MetaMask installed, window should have Ethereum field. But we see some errors here that which says that property Ethereum does not exist on type window. To fix that, we just tell TypeScript window is any. Why is that? TypeScript doesn't know anything about Ethereum. So we tell TypeScript we know that. However, that's very ugly, because always when you use as any, it's ugly. And we want to use some more sophisticated way to tell TypeScript what the Ethereum is, because for now it's any. So we don't take any profit of TypeScript here. I recommend to you this solution, which is a type my window, and we replace the type, we replace any by the type. And now Ethereum is we need to import this from ethers, and now Ethereum is something specific or undefined, but not any. It's not any anymore. In this case, window is my window, which is window and type of global this, and some object which has a field which is optional, and that field is type like this, imported from ethers library. Okay, we get Ethereum, but Ethereum could be this or undefined. Let's check if it's undefined. And if it's undefined, let's throw an error and say no MetaMask detected. Okay, otherwise we want to create a provider, and provider is new instance of browser provider. And browser provider is available under ethers library. It's constructor, so we need to pass Ethereum in here. Okay, this is a relevant approach to create a provider from your wallet, from Ethereum object available under window. However, in this lesson, we only want to show the address of your smart wallet to indicate what wallet is currently connected or is disconnected. So we actually, in this lesson, we don't need that provider. So we commented out. And what we want to do is just to take this Ethereum object and call a method request. And in this request, we need to pass another object with field method. And this method is gonna be like this: if underscore request accounts. And what it does, it's a asynchronous method to request your wallet address, your account address from your wallet. It's asynchronous, so we need to put a wait here, and it returns an array. And in that array, we expect a list of addresses, and the first address and only first is address of your wallet connected to your dApp. So my wallet address. We get some issue. Await is allowed only in async functions. So put async here. Now we have my wallet address, the user address, and we can do something with it. We want to set that address into state. So we need a state. Let's have a state. Use state from React. String. And this is address. Address. And set address. Let's use the setter here. and put that address in here. Okay, we can check what it looks like in browser. It's just like this, connect browser wallet, and if I click that button, actually nothing is happening. So let's provide some feedback to the user representing the state, the wallet is connected or not. So far, we can obtain the address of the wallet, and based on that, we can decide, put an if statement to tell the user wallet is connected or not based on the address. So let's put an if statement in here. If address, then we're gonna return not a button, but just a paragraph, and paragraph displays address like this. Let's interpolate address in here. Otherwise, we want to show the button, because if there is no address present, if address is undefined, we want to prompt user, ask user to connect their wallet by showing the button. And if I go to browser to see my decentralized application, I see my address. It's exactly the same like the address chosen in MetaMask. That means my app is already connected to the wallet. There is no reason to show the connect wallet button like we coded in here. Okay, let's disconnect this account for testing purposes. Go to MetaMask, click in this icon. You see the list of already connected accounts. Click those three dots and disconnect this account. Okay, we need to refresh, and we see a connect browser wallet button is back. Now, if we click that button, we are prompted to choose an account to connect to our dApp. Let's check the first one, click next, connect, and our wallet is connected to our application. So far, I believe you realized that there is one crucial missing feature, which is button for disconnecting MetaMask from our dApp. I can do that from MetaMask UI right here, but this button is missing in the application in here. Maybe instead of just showing an address, I should display a button which says disconnect from this account, from the wallet, from the MetaMask. And the sad news is there is no programmatic way to disconnect your wallet, to disconnect MetaMask from the code, from the JavaScript code in your web browser application. I suspect that wallet developers do that because of some security issues, to not allow developers and also bad actors, the scammers, to just disconnect your wallet. But what developers do in that case? They create a button which usually says the same as this paragraph, which is just display the address. We don't need that paragraph anymore. It's not connect wallet, it's disconnect. So disconnect wallet, another function, maybe in here. And what this function does is just make this address undefined. In our case, it's undefined. So we wipe out the address. So the idea is to pretend there is no address anymore available in the application. However, from the wallet perspective, from the MetaMask perspective, we're still connected to the application. Maybe instead of address, let's print disconnect. Okay, let's check it out in the browser and let's click disconnect. And it seems like we disconnected from MetaMask, but actually not, because every time if you want the user to be really disconnected from the application, you need to ask them to go here and click disconnect this account from MetaMask level. So I click that, and now I'm really disconnected. However, let's check it once again. Let's connect the first account, connect, and we connected back. If I try to disconnect from front-end level, clicking that button, for now I just see connect browser wallet again. If I click that, it seems like a toggle. What we do in the JavaScript code is just setting address from the wallet and wiping out them back. And please note that if I click connect browser wallet, I don't need to go through that process when I click disconnect in MetaMask. So I don't need to confirm again in MetaMask. I want to be connected to this decentralized application. I don't need to do that because we actually are not disconnected from this application. We're still connected. What we do is only wiping out the address. Let's tweak this button a bit. Let's put it in some frame to make it look nicer. So okay, I put both buttons to the box, which is actually a frame, and the logic of displaying those buttons didn't change. Instead of if statements, I use inline conditions, but this is the opposite condition. Let's test it out. Yes, we get a nice frame with nice shadow, and everything looks amazing. Hey there, in this lesson we're gonna create controls for sending transaction to our smart contracts right in this place, and it's gonna look like and behave like this store button. So we're gonna trigger a transaction. Okay, start from JSX. Let's create another column with a button. Button is going to save our transaction, save value. We can create that function in here. For now it's empty, that's okay. And save number. We get button here and button here. Perfect. If I click that button, nothing happens. So let's fix that. The next dude is input, and that input is type number, and it got class name input, and let's add some margin. Okay, we have input, we can type into it. Let's log the number, the typed number in the console when I click this button. Let's do that. In save value function we created in here, I like to have input variable like this, and I get access to that input and its value via document get element by ID. The ID is input. Let's put the same ID in actual input ID input. Okay. The value of variable input can be HTML element or null. So let's check if it's not null. If it's null, then throw an error. Just input not available. Okay, there's a back exclamation mark here to say it's not. Let's take an input value, but value is not available because input is HTML element. We want it to be HTML input element. So let's wrap an input variable and assign a new type HTML input element. Yes, like this. And this is our payload. So put it into payload variable and log that value, that variable payload in console. Okay, let's check it out in browser. If I put some number here and click save number, I see payload in console. Let's put that value into transaction. We want to revoke another smart contracts function, so we probably need this code. Async is missing here. Okay, error is gone. Let's find transaction name, the smart contracts method name. Let's go to ABIs and we see two items. First one is for retrieve and the second one is store. And we see store accepts some inputs and it is some number. Okay, let's use the store method of the smart contract, of the store smart contract. We could invoke that function, but it's going to fail because we can't use the public provider, the standard provider, what we use for reading data. We need to use a signer instead. Okay, so let's have this code available only for get value, only for reading, and for writing to smart contract, let's create something similar, but instead of this provider, we're going to put in here a signer object. We don't need this console log anymore. And let's create a state, another state for wallet provider. And set wallet provider. And the type is browser provider. It's imported from ethers library. We can retrieve wallet provider from wallet component right in here from Ethereum. So we can provide some callback in here and pass wallet provider via argument. Let's create wallet provider and pass it to callback. Callback is on connect. This function doesn't exist yet, so create props interface, and one of the prop is going to be on connect, and this is a function, return type void, and accepted argument is wallet provider type browser provider. Okay, let's use it. Props type in here on connect. We get access to onConnect method and error is gone. Everything's fine. Let's go to store element and we see there is a missing prop onConnect, and this callback is actually the setter for wallet provider. So let's pass the setter here, and we expect once we connect the wallet provider is available under wallet provider variable from React state. That's not everything because we can't provide wallet provider like this because it's going to fail. We need to have a signer object. So let's have a signer by wallet provider get signer like this. Await is missing here. And this signer is either JSON RPC signer or undefined. So we need to check if it's not undefined. Let's use that if statement and replace input by signer, and let's shut out that signer is not available, or rather wallet is not connected. Okay, now we can use signer here because we're sure it's available, and let's pass the payload to the store method. We don't need to have access to result. Okay, let's test it in the browser. Refresh the page, put some number, save number. Wallet is not connected. We get an error as we expected. So let's connect the wallet. Wallet is connected. Try again, save number. And now MetaMask prompts us to confirm the transaction. Now let's check what's the number inside the smart contract. Get number, let's click it, and we see the values are equal. So let's change this number again, 5555, save number, confirm transaction. Let's wait for transaction to be mined. Then click get number again, and we see it's 5555. Perfect. Now you know how to write to the smart contract using your wallet provider and how to use signer object.